said, we have the great pleasure to have Dunnebacke with us. Most of you already know her. I learned everything I know of Amoeba, reading her articles and going to Congress with her. So for me, it's a great honor to introduce you and have her first presentation here in the World Congress. So thank you very much.
Today I'd like to tell you a story, but it started 6 years ago. And sometimes things just go more slowly than other things. But anyhow, it's still ongoing. 6 years ago, the lab received some tissues from an encephalitic victim, and the question was the source of the encephalitis. We did the fluorescent antibody staining of sections from the biopsy, and in fact, there are a lot, one thing. There are a lot of amoeba reacting to the fluorescence, and so this is a Balamecia amoeba syphilitic victim. Okay, we saw the amoeba, the people gave us, we had lots of tissue. We had 3 samples of fluid from the man underwent a biopsy. Then we had, in addition to the fluids, we had sections of the brain. This is a good Balamecia case. Okay, we've got amoeba. We're going to get the amoeba out and check them because we wanted to compare them with the ones that we had, because it seems to me that Balamecia ought to vary a little bit. You know, they had personalities, and so we just wanted to check them. So we had the tissues, we put the tissues on monkey kidney cells, fully expecting, fully expecting to find some plaques. These are monkey kidney cells. They had the samples from the patient put on them, and the amoeba grow. That is, most amoeba from most samples, when you expect them, grow. We got something very different. We got, instead of this, we got these cells. Now, these are not Balamecia. In fact, these cells were put on this monkey kidney sheet 2 days before. It takes 1 to 2 weeks for the plaques to show up. But these cells were growing on the surface of the monkey kidney. And the thing is that they didn't seem to affect the monkey kidney. These are cells growing on top of something that's not affected. That seemed very strange. The other thing is the cells were really different looking. They're mottled, and some of them have what I was calling little proboscis, here and here. But we kept looking for the Balamecia, but we kept getting these when you transfer, and after between 2 and 3 months, we found something else. But then when we started culturing these cells in just medium, without the fetus cells, we found that they grew perfectly well. They were slow, which meant that they got changed every 4 weeks, sometimes 6 weeks. But that's okay, we can do other things in the meantime. But the thing is, we were looking for these. We've got those. And now we put them under digital contrast microscopy and look at the model covering. And they had little spikes sticking out of some of them. Now these look really different from monkey kidney. They look different from other amoeba. But now we knew that the Djerba-Zarzis was in the tissue, the samples, because the person had the Djerba-Zarzis. But we looked at some of the cells which did not grow plaques. We were looking and we found there are Djerba-Zarzis in the cultures, but none of these cultures had active Djerba-Zarzis making plaques. So what are these guys doing? And look at them. Why are they so clustered here and here and here? Now, if we did know that we got Djerba-Zarzis and we got these things, and we didn't know what they were. So, in order, the models covering looked hard, and so we put some, they looked like they had calcium or something, and calcifluor is a stain that is specific for calcium. So now our unknown cells, which we would call unix or unexpected, the unix now that has calcium, and it tends to be at the edge of the cells. Now, if we have these, that's a marker. The calcium then would be a marker for the unknown cells. We took the unknown cells, we sent them to a company to make antibody, and we found that the antibody also is perinuclear and at the edge of the cell. Now we have a way to identify the unknown unix cells, and the difference between them and the Djerba-Zarzis. And if we do that, and I want to go back, then we looked again, and we found that the unknown cells didn't mean to be so jumpy here. The unknown cells now stain with the antibody that we had made to unix. The big question is, are these crazy unix cells, are they in a man's brain? Or is this a contaminant we picked up? Because tissue culture is really good medium for all kinds of junk that falls out of the air. But look, we now have a means of looking in the man's brain to see if these now are falling out of the air or if they were associated. So then we started looking at the sections of the man's brain, and we found that the sections unstained, just looking at a section, it had these very dark areas, these dark cells, which are unusual because this is unstained, it just had the paraffin removed and looked at it. Now, if they're dark like that, they also, in those areas, had amoebas. This is stained with the Djerba-Zarzis antibody. So now we have the antibody and the amoeba in the man's brain. We also had antibody to the unix and a section of the man's brain, and the unix is in the man's brain. Now, the problem was that both of the antibodies we had were stained with FITC, given a green response, but we knew that the unix of crazy new cells had chitin in them, and they stained with calcifluor. So if we take a section, stain it first with calcifluor, and find the unix cells in the man's brain, and then counterstain that with the Djerba-Zarzis antibody, and we find that the Bellevue antibody. Anyhow, the Bellevue antibody is the green staining in the background, and the whitish is the unit cell. So now we have the units and the amoeba both in the man's brain. So what we have is not something that fell out of the air, but something in the man's brain. So what is this thing? We found more crazy that in addition to being in the man's brain, the green staining Bellevue there and the white staining unit cells were really close together. They were almost contingent little pockets of them. But then if we look more, not only are they close together, but they're also in the lumen of the vascular system. And if they're in the lumen, well, they have to get there somehow or another. And that's an entrance into the brain. So it seems logical that maybe the units and the white staining units and the Bellevue there were somehow or another conjoined or together. Now, what does that mean? Is that happenstance that they just happen to be there together? So we started looking now at the units separate to find out if we could what it was. We found if we put the units on a lawn on agar, we found that they have these strange large cells that look like they have the small cells come out. The small cells are about 7 millimicrons. The large is more than 20 millimicrons. But there's a little suspicious something happening here, some association. Then we looked more closely at the individual unit cells, and look, on the edge, it's dark. And down at the bottom, they look different. And these move. You can watch them, and if a Bellevue is nearby, the unit cells really put out more of these funny feed-like things, and they seem to be talking to each other. And they do talk to each other, because now some of the units are lazy and they just kind of sit there. But the Bellevue is active, and if you look, you see that the Bellevue and the units, the Bellevue walks almost like it walks up and touches the units, and then it might move away and come back. It's like the units and the Bellevue, well, the Bellevue is teasing the units, and then eventually the Bellevue captures the units completely wrapped in the pseudopodium, and it stays that way. But see, the pseudopodium of the units is really working and changing, and then zap, all of a sudden, the units get shot out. But look at it, this unit is crushed compared to that one. So the Bellevue has captured the units and squished it, and this shows that it was indeed, it had a calcium tightened shell. Now, something else that they do. The units can move, and they can get associated with the Bellevue, and they seem to be stuck there. And then actually more units will kind of join, and they are really pretty tightly packed here and here. And occasionally it looks like a Bellevue is going to crawl away, but instead it gets recaptured and recaptured, and then all of a sudden the Bellevue stops moving, and 10 hours later it's vanished. Except the nucleus of the Bellevue is present, the rest of it's gone, and there are a lot more units around. There's one conclusion that it is the Unix is eating the Dunnebacke. Now, if you just read, okay, the Unix eats the Dunnebacke, but the Unix by itself, what is it? If we look, we see that the Unix have a dark capsule covering in bacteria media. If we grow these in fungal media, they're clear. So they're changing color with the medium conditions. And if we look carefully, we find that in addition to these 7 to 8 millimicron units, there are smaller cells. At least they look like cells. And these are 1 to 2 millimicrons in diameter. So something is happening that these cells and these very small cells are together. But now the problem is in tissue culture, it's very easy to get contaminants, and the contaminants will grow in different ways. But if we look at these cells that have been in culture for years, plus these cells, what I did, which I'd forgotten about, is I had put some of these cells in a tube, screw cap tube, and put them in the dark in the lab, and forgot about them. So 4 years later, I took them out, put them on monkey kidney cells, and here they're growing. And they look like the original cells. So we have cells that are like the original, close to the original, plus ones that have been in culture for 6 years, and they look the same. So then we look again, and we see that these cells have little projections coming out. And this one just is rumpled on the side. And then we see occasional cells like this. Now this, when we first isolated the Unix and was looking at it, I kept seeing cells like this, not knowing what they were. And they had these long projections. And so I took a little movie of these, and this is vibrating like a string on a violin. What that means, I'm not sure. And then, in order to be sure that we're working with the same things we started with, if we take the cells that have been in culture, treat them with calcifor, they have calcium on the outside. By all of the criteria that we can tell by looking and staining, these cells are like the original cells, so these cells must have come from the patient's brain. And then one day, you know, the roof fell. Here I found these clusters of hyphae. Hyphae are fungal. So I thought, you know, we just messed up. And so I threw out those cultures, and I left some more. And I decided to these take 4 to 6 weeks between transfers, and so I'll just leave them and let them get dry. But this is an interesting structure. There's the calcium on the outside, and these are these growths on the hyphae. So if I could repeat this by letting the structures dry, then this must be material in the culture. It's not something from the outside. Then if you start looking at the cultures, you see that they have these structures. Now some of the big cells all of a sudden seem to be getting into a line. And then we have more lines. These are the hyphae, and they're packing themselves into a line, and like this. Now this is typical of a fungus, and then we have these. This now is a line of those hyphae, and if you look at the hyphae, they are a string of the little cells, and you can see the little cells here. So we have a fungus. Who is it and what is it? It's the same cells that we started with, and sequence ending found that what we're working with is Aspergillus terras. The Aspergillus is the same as we started with, and these are eating the amoeba. Now the thing is, the sample that this came from, the person was treated for more than 2 years. He's now a survivor. He's now a healthy, active, regular person. The thing is that the Aspergillus terras, pathologically, is determined by hyphae in a man's brain, a person's brain. But what we found was not hyphae in the brain, but these unique cells. This is very different because Aspergillus is diagnosed by staining cell sections, and the staining is low clusters of hyphae. So we have cells that were growing in the man's brain. These cells interact with the bowel mucosa, killing the bowel mucosa. And so my hope was that by having the units in the brain was helping the man by eating the bowel mucosa. But of course, that's just daydreaming. So all we know now is that this person had Aspergillus terras, which was interacting, which could interact with the bowel mucosa. Now, after multiple treatments, the man is alive, and the cultures of Aspergillus terras are still in the lab, and they're still growing. Thank you very much.
So, we have some time for some questions.
Yes?
So, in your opinion and your view, okay, you think that this Aspergillus, in a way, helped the man survive? Do you think that the co-infection, you think that Aspergillus actually it favored the person's survival by killing Balamuthi?
I think the thing is, ends up being the hyphae.
Okay.
And the hyphae then have the cells inside
Okay.
the conidia, and then the conidia actually gets so multiple that it kind of makes a sheath like a cell layer.
Okay.
And the conidia then, actually what this happened, I've taken cultures that had just conidia, put them on monkey kidney, and they look like the wisdom. So that it's a whole, I mean, I think we can say that there's a whole cycle
Between.
of the terrorists.
But here, in your follow-up, okay, you saw that Balamuthi was killed by this Aspergillus, isn't it? The Balamuthi
Yes.
was actually attacked and killed by this Aspergillus. So in a way, the person was saved.
Right.
He got help because of this Aspergillus, which actually killed the Balamuthi, because Balamuthi patients don't survive that much. I mean,
I can't answer that, but the thing is that the terrace grows in dirt,
yeah,
in the dust. The amoeba grow in the dirt,
yeah.
in the dust. People inhale. The Aspergillus is known to be pulmonary.
Usually, yeah.
Infrequently, it can also be in the brain. The Balamuthia can be breathed in. And if the Balamuthia and the terrace are together, and the terrace is eating the Balamuthia,
It's like saying,
they're found in the lumen of the vessels the brain, is that not a pathway? Have they not been together?
Maybe.
This is all daydreaming.
Yeah.
But have they not been together in the dirt and the dust and found a healthy man doing that?
So this person was not in any way immunocompromised or diabetic or he had some immune suppression or he was a perfect healthy person?
That's a whole other ballpark.
Okay.
And I think there's a connection, but I don't have data
Okay.
for it. But it seems to me that there's something tricky going on between the immune system and the bowel there.
That I was thinking.
And I'm sure there's some tricks going on between the terrorists and the persons. But there's a chance, that's a daydream,
Okay.
that the terrorists and the Belvedere is eaten by the terrorists, but the cysts are not. So that if you have two cultures together, they'll both survive because the cysts survive and the terrorists certainly survive. The terrorist seems indestructible.
It looks like
At least around me.
yeah.
And if they're all together in the dirt, maybe this is a natural
Good.
habitat system
Maybe, yeah.
that just happened to get into the man's
Right.
lungs or whatever. And I think the man is lucky,
It is. Yeah.
and I think something's going on. I think there's a secret. We don't know yet the answer.
Okay. Thank you, Louis. Thank you.
Any more questions?
Hi, Tony. To which temperature it was all the experiments of feeding, or to which temperature of
Somebody's
the temperature?
Pardon?
Yeah, the temperature of the experiments, or did you maintain the Baramutia and the fungi at the incubator at 37 or up to lower temperature?
You mean a serum interaction? Yes. When the Belvedere gets into the body, via whatever mechanism, the skin abrasion or inhalation, they get distributed in the hepatogenous system. If the terrorist, we don't know because it hasn't been followed in that same way, except the terrorist is inhaled. It gets through the whole blood system. It can get to the brain. But why not have the Belvedere and the terrorist going along together? The terrorist is eating the Belvedere, but they don't eat it all the way because they're still Belvedere because the cysts are not eaten. So it's like having two populations that are somehow imbalanced. The terrorist is eating the Belvedere and the Belvedere is insisting to save itself.
When I saw the fixed pictures, it seems to me that probably it's like yeast form. And that my question is, if your experiments were done to 37, and if the yeast become the hyphae or the filamentous fungi to the same temperature, or because they were dry, or you led to the room temperature to let them dry, because it's clear that some fungi they grow like a yeast form to 37, and when they move to 28 or 30, they change to the filamentous
I
form.
can't answer that, but the thing is, I do know that the terrorists survive on they grow slowly at 37. They hang around for years at room temperature in the dark, or I haven't tried them in light, but they stay there. And who kills them? Seems to me, from what we've found out, that the whole world should be swarming in aspergillus terrorists. But I'm glad that somebody comes around fingers crossed.
Okay, thank you.